Hi again, guys. Here is Clement. I'm continuing on the topic ionic equations. Last time we talked about on how to write an ionic equation. Today I'm going to teach on the basics of ionic equations, which is solubility rules. Because for you to be able to write an ionic equation, you have to know which salts or which compounds are able to dissociate into the ions. And for us to cover that, today we are going to look into the solubility rules. The solubility rules, these are the rules that guides us or that help us to know and to recognize the salts or the compounds that are soluble or that can be ionized or that can dissociate into free ions. Yes, here we have different compounds, metal compounds, and we have different anions which can form an ionic compound. So the first of we have the group 1 ions. Group 1 ions are the ones that comes from the group 1 metals in the periodic table, which is the alkali metals. We call them the alkali metals. They are the ones which are the group 1. So all the salts of the group 1 metals are soluble, all of them. We can think of sodium carbonate, we can think of sodium chloride, potassium sulfate, all of them, all of the salts which are formed from group 1 metals are soluble. And we have another cation there, which is ammonium ion. Ammonium ion it's a radical. We call it radical. It's a radical. And then we say all of these ammonium ions. Ammonium ions, an example we can talk of what is it? Ammonium carbonate. Ammonium carbonate, it is soluble. We can talk of ammonium chloride, it is soluble. All of the ammonium salts are soluble. And then we have the nitrate there, the nitrate. Lower name, it is also a radical. It is also a radical. All of these salts, all of the salts that are made up of or that contain a nitric ion, they are soluble. All of the metals, either group 1, group 2, transitional metals, and group 3 metals, all of these metals that contain a nitrate anion, they are soluble. We can think of any. And then we have the halides. The halides are the ones that are in group 7. Group 7, the non-metals in group 7, which is fluorine, chlorine, bromide, iodide, and astatine. Those, all of them, we call them the halides. That group, we call them halides. They are soluble. They are all soluble, except when these halides are combined with silver. When a halide is combined with silver, it forms a precipitate. It forms an insoluble compound. And we have lead 2. Lead 2, we know it as PB. Lead 2, it is known as PB. So all the halides which are combined with lead, they are insoluble. So under halide salt, we can say that all the halide salt, group 1 halides, group 2 halides, transitional metal halides, they are soluble. Group 3 halides are soluble. But as it comes for except the silver and except the lead, these ones are insoluble. So whenever compound that we have, which is a lead chloride, a silver bromide, they will form an insoluble compound. So we notify them as solids. And we have the sulfate ions. This one here, we call it a sulfate ion. Sulfate, it is also in the group of the radicals. We call them as sulfate ions. And one thing that you have to know about sulfate ions is that all sulfate salts are soluble, except these 3. Except the barium sulfate, except the calcium sulfate, and except the lead 2 sulfate. Except these 2 sulfates. But as for all of the other sulfate salts are soluble, they will form what we call an aqueous solution. An aqueous solution, like I said last time in the last video, is that an aqueous solution is a solution that is able to dissociate, that has been dissolved in water. It is able to dissociate into its free ions. So these three, 1, 2, 3, barium sulfate, calcium sulfate, and lead 2 sulfate, they form a precipitate. They form an insoluble salt. And we have another salt that is called calcium carbonate. It's a carbonate salt. A carbonate salt is any salt that has CO3 2-, and it is also an example of a radical. It's a carbonate salt. All of these carbonate salts are soluble. All of them, they are soluble, except the ones that, all of them are insoluble. All of them are insoluble, except the group 1 carbonates. Like I said, all the group 1 salts are soluble. So, which means that like this one, the carbonates, it says that they are all insoluble except the group 1, because the group 1, we call them the alkali metals. The alkali metals, that are the easily dissolved metals. So any salt that is formed of the group 1 metals, it will be soluble. So we have they gave us I gave an example there. Sodium carbonate is an example of a group 1. Potassium carbonate is an example of a group 1, and ammonium carbonate. Now you will remember that under ammonium, I said all of the ammonium salts are soluble, and I gave an example of ammonium carbonate. So those are the only 3 examples of the carbonate salts which are soluble, and the rest of them are insoluble. So we can say that the group 2 metals with carbonate are insoluble. The transitional metals with carbonate are insoluble. The group 3 metals with carbonate are insoluble. And the group 1 metals with carbonate are soluble, plus ammonium, which is a radical. It is the only radical with a cation or with a positive charge, and it is the only one that is soluble with carbonate. And then the last one, it is a hydroxide. A hydroxide is an OH-. All of the hydroxides are insoluble. All of them, except group 1 hydroxides. All of the hydroxides are soluble. We know that the hydroxide are alkalis. That's why the group 1 metals are called the alkali metals. It's because when they are combined with a hydroxide, they form a soluble compound, or they form a soluble substance. That's why we call them the alkali metals, because a hydroxide, every compound that contains a hydroxide is an alkali compound. So the only metals that gives these properties are the group 1s. That's why they are soluble when they are combined with a hydroxide. So then, which means starting from group 2, transitional metals, and group 3, they are all insoluble once we combine them with a hydroxide. So those are the solubility rules for the O level. The O level, the GCSE group, these are the solubility rules that you should know, and you should remember them at all times. Because the moment that you know these ones, I assure you that any example, any group any question that can come for forming ionic compounds, you are able to do it. Now, let's take an example. This is the question that I took from the exercise that I gave last time, so I'm just going to go over it. The question says, write the ionic equation for the precipitation reaction between calcium chloride solution and sodium carbonate. I wrote down the equation there. So what is remaining just for us to balance the equation? Like last time, like I said, that the conditions for you to be able to write an ionic equations, first, you have to balance your equation. So you have to balance our equation, and then secondly, include the state symbols. So we have to balance our equation. We'll balance our equation by including a 2 as the sodium chloride on our product, and this makes our equation to be balanced. then we have to include the state symbols. The state symbols, for you to include them, we have to remember the solubility rules. Calcium chloride. Calcium chloride, this means it is a chloride salt. And we say that all of the chloride salts are soluble except only the two. So calcium chloride, it is soluble, which is, we are going to denote it as aqueous. And then sodium carbonate, we said all of the carbonates are insoluble except group 1 carbonates. Group 1 carbonates are sodium, are potassium, and so forth. So which means that this one is going to be aqueous. And we have calcium carbonate. We said all the carbonates are insoluble except for group 1. And calcium is not in group 1, it is in group 2, which means this is going to be an insoluble salt, which is a solid. Sodium chloride, it is in group 1, it is an aqueous. Now you have included your state symbols. What is remaining now is for you to dissociate what has to be dissociated. Now you have to write, because calcium chloride is an aqueous, you are going to dissociate it. 2 plus, include your state symbol. Plus, you have two chlorides there. So you are going to write the number of them as 2 chlorides. You see, you are taking this 2, which is a subscript. Now you are taking it to write it as a whole number before the chloride. Because this means that we have 2 chlorides. Plus, the same thing applies to the sodium ion. We are going to take it, it's going to be 2 sodium plus aqueous, plus carbonate is a 2 CO3 2 minus carbonate, which will give you calcium carbonate is a solid. That means we are not going to dissociate it, we are just going to write it as it is. Calcium carbonate, it is a solid, which gave us 2 sodiums plus, because this 2 means that we have 2 sodiums and 2 chlorides, 2 chlorides, then aqueous. Now you have written the ions, you have dissociated the compound that needs to be dissociated. Now what is going to happen is that we have to cancel out or cross out those ones which we call them the spectator ions. The spectator ions are the ions that appear on the product side and also on the reactant side. They do not participate in forming an ionic equation.